Alright, here we are, class number 9, our last class of the astronomy lectures. So in this one we're going to cover 4 topics instead of our normal 2. It's because we're at the edge of our solar system now and we don't know as much about the planets at the edge of our solar system. So Uranus, Neptune, Kuiper Belt, and Pluto all covered in this last lecture. And if you remember, in the closest to the Sun we have the terrestrial planets, and then after that we have the asteroid belt. After the asteroid belt, we start with our gas giants, and the last 2 of the gas giants are Uranus and Neptune. What they have, these 2 planets have in common is they're both a bluish-green color. The reason for that is, it's a gas giant, is a little bit of terrestrial planet, and then mostly a huge atmosphere. This atmosphere is made up of methane gas. Methane gas absorbs red light, and it reflects blue light. So because it's reflecting the blue light back, they both have a bluish appearance. Of the 2, Neptune is the bluest because it has the most methane. So think of it, that Neptune, the god of the sea, the deep blue sea, and help you make that connection that Neptune is the darker blue of the planets. So let's get on with it and review these 4 subjects. So on to the first planet, Uranus. A lot of odd and interesting facts about this planet. So first of all, most planets have a north-south axis and they rotate horizontally like this, where Uranus has almost a 90-degree tilt, so it rolls like a ball. This tilted axis makes it look, and it also has rings like Saturn and all these other gas giants, and the rings rotate in the same way, so it almost looks like a wheel, or like with the rings, like a big wagon wheel wobbling around through the solar system. So a little different than most planets. Also, most planets rotate counterclockwise. However, Venus, Pluto, and Uranus move in a clockwise direction. So it actually goes the opposite direction of most planets. Very cold planet. It's negative 350 degrees. It's actually colder than Saturn. And I think that just about covers all the odd facts. So then different names. Most planets in the solar system are named after Roman gods, right? Like Neptune, Jupiter, these different Roman gods. Well, the 2 moons around Uranus, Cordelia and Ophelia, they're shepherd moons like the ones around Saturn that are in the rings and help hold the material in the rings in orbit. Cordelia and Ophelia, instead of being named after Roman gods, were named after Shakespearean characters. So it kind of broke with tradition there when they named these moons. A couple other normal facts. The orbit of Uranus to go around the Sun is 84 years. Quite a long time. Might make it around once in your entire lifetime. And then the day isn't too far from Earth. It's a 17-hour day, so it has a pretty fast rotation. 84-year orbit, 17-hour rotation. I might have just said day there. 17-hour rotation, pretty close to the Earth. As far as the discovery goes, Uranus is one of the most recently discovered planets. It was in 1781, and it was discovered by William and Caroline Herschel. So these 2 discoverers, these 2 astronomers, were actually kids. They were homeschooled kids, and they were musicians. Their dad was training them to be a musician and an amateur astronomer. And so they saw this light that they were observing for a period of time, and they thought it was a comet. And then as they began to follow it, they realized that it had a circular orbit and discovered that it was actually a planet and not a comet. So 2 homeschooled kids discovered a planet. Maybe you guys with your telescopes will discover a planet someday. They pretty much think they found all the planets in the solar system, but hey, you never know. It's a big, wide open space. So keep searching those skies. All right, on to the next planet. On to Neptune, the next planet. First, it just dawned on me I'd probably better introduce both the planets visually. So here is a planet of Uranus. So you can see how it's on its side. Not bluish, but not quite as blue as Neptune will be. The rings going in a different direction, the rings going north and south rather than around where the equator would be. And then if you look at Neptune, Neptune is the bluer of the 2, still has rings, Just wanted you to get a quick visual, get an image in your mind of Neptune and Uranus. So Neptune is the brightest blue because of the gas methane. Hope you remember that one. It was found because of a deliberate search for something that was pulling on the planet Uranus. They were noticing some kind of like a pull and a wobble, so they systematically and deliberately searched until they found Neptune. They think it's the last of the planets. Who knows? You know, there's always more to be discovered. But they think it's the last of the planets. It's also very cold. It's negative 370 degrees. I think it was negative 350 was Uranus. So they're getting colder as they go out there further. Neptune, as far as all these gas giants, it's the smallest of the gas giants. The core, the terrestrial core, is about the size of Earth. So, you know, picture Earth with an atmosphere that just keeps going and going and going. The orbit around the Sun is about 164 years to get around the Sun. That's almost 2 times how long it takes Uranus to go around through the solar system. So 164 years. Pretty close on the length of a day. It's a 16-hour day. So the I don't know, it's compared to a 24-hour day on Earth. It's a pretty fast day. So that probably has a lot to do with why there's storms in the atmosphere, that fast spinning, stirring things up. It also has a striped cloud pattern like most of the gas giants, which are storms. On Neptune, it'll have dark spots, which are kind of like the red spot on Jupiter, very concentrated storms. The hypothesis that they have on this planet, because there's so much methane, is that it might actually rain diamonds, not like, you know, diamond rings, but like industrial diamonds, because they did an experiment a while back with methane gas and found that it can form into diamonds. So it's just a hypothesis, but they think maybe the whole planet rains diamonds. Interesting. As far as the number of the planets from first to last, Neptune and Pluto have this really strange thing. Pluto will actually come inside the orbit of Neptune. So normally Neptune is the 8th planet, but then when Neptune for 20 years, so it takes 164 years to go around the Sun, 20 of those 164, Pluto loops inside the orbit of Neptune, making Pluto the 8th planet instead of the 9th. So there's just like a little gap every once in a while that makes Neptune the farthest out planet. There are 10 moons on Neptune that have been discovered, the biggest of which is a moon called Triton. Triton is the coldest object that any vehicle or any man-made thing has been able to get to and measure. It's negative 400 degrees. So we had negative 350 with Uranus, negative 370 with Neptune, negative 400 on the moon. And I'm sure there's some variation in the temperature, but that's just what the textbook had them recorded as. So Triton is the coldest. Another interesting thing about the moon Triton going around Neptune is that it rotates clockwise. Remember how we've been talking about how most things in the universe go counterclockwise? Well, Triton rotates clockwise. And then here, if you look at this picture, you can see the other thing that's noted on Triton is that it is covered with geysers that spew chemicals out into the atmosphere. Very odd for a moon. Usually the moons aren't quite so active, but Triton is a very active moon that has chemical geysers all over it. So on to the Kuiper Belt. So beyond Neptune is the Kuiper Belt. The Kuiper Belt was found in 1992, which was the year I graduated high school, by Gerard Kuiper. He found it because he had an educated guess. He believed it was out there, so he kept looking until he found it. He believed it was out there longer than 1992, but he actually discovered it and was able to find it in 1992. So the Kuiper Belt is kind of like the asteroid belt that comes after Mars, except it's much bigger because the orbit around the Sun is much bigger as you go out from the Sun. It has a lot of different objects in it. Many of them look like comet nuclei. So that's why they think that the Kuiper Belt is the source of short period comets that come in from the Kuiper Belt into our solar system and then back out. There's some in there that are really big called Plutinos, and that's like little Plutos. So it's kind of like the planet Pluto except smaller. So we'll get into that when we talk more about Pluto. So the Kuiper Belt, compared to the Oort cloud. So when we talked about the Oort cloud being this thing where the long period comets come in from, and the Kuiper Belt being where they think the short period comets come from. And again, this is mostly hypothesis, they don't know for sure. So Oort cloud, bigger, huge cloud around the solar system, they think is for long period comets. Kuiper Belt, out there past Neptune, they think is where the short period comets come from. The Kuiper Belt's more like a ring, the Oort cloud's more like a cloud, and there's a big difference in size. So try to picture this all together. Think of like belts holding things together, or belts making a division. So we've got the terrestrial planets up till Mars, and then there's the asteroid belt. Then we have the gas giant planets up until Neptune, and then there's the Kuiper Belt. And then all around the Kuiper Belt in this big cloud is the Oort cloud. So that's just kind of how I picture it, is just these belts dividing up areas of our solar system. The planet or not planet Pluto? So that's the question. We're going to have a debate in class. We're going to prepare with all the arguments for Pluto being a planet, all the arguments against Pluto being a planet. Up till now, I've been treating it like a planet because otherwise the very, very early morning would start under Nancy instead of Nancy's pancakes. So we're going to keep the pancakes and keep Pluto as a planet. But it does have some odd features that got it voted out. Some real simple ones we'll cover more in the debate in class. But Pluto as a planet is more like an object from the Kuiper Belt than it is the other planets out past the asteroid belt. So one of the really odd things is that it has a strange elliptical orbit. Instead of one that's more circular like the other planets, this orbit comes from, it extends out into the Kuiper Belt and comes all the way inside of Neptune. So sometimes it's the 9th planet, sometimes it's the 8th planet, sometimes it's in the Kuiper Belt, sometimes it's not in the Kuiper Belt. So it doesn't really stay in the same position to the other planets. The other odd, big time odd fact is that it's not a gas giant. Once we get past the asteroid belt, then every other planet's a gas giant. But Pluto's not a gas giant, it's more just like a hunk of rock. So it makes it not really fit the pattern of terrestrial planets, asteroid belt, gas giants, Kuiper Belt. It's just kind of a strange phenomena out there at the end of the solar system. So if it was a planet, it's odd too because it rotates clockwise like Venus and Uranus. It also lays 90 degrees, so instead of spinning this way, it rolls like a wheel. Just one of those other weird phenomena that's kind of opposite direction. To get one orbit of the planet Pluto takes 240 years to go around the Sun. Since it's been discovered, it's only made it 1/4 of the way around its orbit. It's currently in winter and has been in winter ever since we've discovered it, and it's gradually going to be moving towards spring, so scientists are eager to see what's going to happen when it kind of changes season. So let's add one more picture. So here's a picture of Pluto, just to get an idea of what the planet looks like. And then this next picture here is Pluto and its moon Charon. And Charon and Pluto are very strangely close in size. I mean, obviously Charon still looks like the moon, it's still smaller, but the percentage or the ratio, let's say from our moon to the Earth, Charon almost looks like another planet. So sometimes scientists wonder if it is a twin planet and two planets orbiting around each other. So just a hypothesis, one of those great wonders. Alright, so that covers the last of our astronomy facts. Just kind of chunked everything together there at the end with these outer planets. But when we get to class, we have one last final experiment or last project, which is the debate, just to compare and contrast the facts and the reasoning behind whether to include Pluto as a planet or not. And looking forward to that. I'll see you guys in class shortly.